Chris Potter. Today is Tuesday, March 28th, 2017. I have a new presentation. Is there a large object close to the Earth in March of 2017? A physicist's thoughts. Let's begin. Figure 1 below shows an HI1-A image showing the Earth with a black area next to it, indicated by a blue arrow. The dark area is a possible indication of an object being to the left or behind the Earth. Figure 1, HI1-A image from February 28, 2017 at 1609, showing a dark area to the left of the Earth and indicated by a blue arrow. Figure 2, HI1-A images from March 17, 2017 at 9 minutes and March 18, 2017 at 2:09. The dark area to the left of the Earth is still present. Figure 2 shows that the same dark area is still present. On March 17th and March 18th, 2017, but the vertical line that's associated with planet Earth, or the Birkeland current, seems to become two lines, almost superimposed on each other on March 18th. These vertical lines are associated with the light from bright objects and the image overwhelming the camera. Now in figure 3 below, we see the vertical line associated with Earth. Again, a Birkeland current. And the line to the left becoming increasingly separated, suggesting that the object to the left of the Earth is probably being left behind by the Earth. Figure 3. HI1-A images from March 19, 2017 at 22:49 and March 20th, 2017 at 18:49. The dark area to the left of the Earth is still present, and the vertical line associated with planet Earth and the vertical line to the left of it become increasingly separated. Figure 4, complete HI1-A image from March 23, 2017 at 20:09, showing that there is no bright object along the vertical line to the left of the vertical line associated with planet Earth. Again, the Birkeland current. Figure 4 shows an HI1-A image from March 23, 2017. There is no bright object anywhere along the vertical line to the left of Earth. This suggests that the object behind the Earth is the source of the vertical line to the left of the Earth, and that the image has been manipulated to hide the object so that only a dark area remains. This fact is again illustrated in figure 5 below. Pardon me. Figure 5. HI1-A image from March 25th, 2017 at 4:09. The blue arrow indicates the vertical line associated with Earth. The yellow arrow indicates the vertical line associated to an object close to the Earth that seems to have been purposely hidden. Figure 6. HI1-A images from March 16, 2017 at 9 minutes and 16:07. The sun seems to have one of its violent reactions, probably due to another star in the close vicinity. The dark area to the left of the Earth this time looks much larger in the right image. The fact that that dark area to the left of the Earth looks so much larger in this image on the right of figure 6 indicates that the objects hidden in these images are a lot larger than the small dark area seems to indicate. The object associated to the dark area to the left of Earth seems to stay very close to the Earth for a very long time. Pardon me. Suggesting that it has an orbit around the sun that closely matches Earth's orbit. And that it is behind and close to the Earth as well. In fact, that dark area, and therefore the object associated with it, was still present close to the Earth in November of 2016. In addition, a large object appeared in the HI1-A images between November 21st, 2016 at 4:09 and September 23rd, 2016 at 16:09. The object does not look like it could be a lens flare of any of the bright objects in the image, namely Earth and Mercury. It must therefore be a real object. And it's also an extremely large object. Figure 7. I want to point out that this looks like it has ridges and valleys and has depth to it. There are other pictures of the same object and other HI1-A and SETI images. Figure 7, HI1-A images from November 21st, 2016 at 4:06 and November 23rd, 2016 at 16:09. A very large object appears in these images. We also see a sustained and very large plasma ejection on the left of both images in Figure 7. This plasma ejection remains constant during the intervening time and does not seem to be due to a CME, coronal mass ejection, from the sun. As CMEs from the sun usually travel away from the sun, so there again may be a large star producing the constant ejection on the left of both images. Since the large object in the background is too large to be anything but a star, we possibly have evidence of two large stars in these images. Figure 8 on the left, HI1-A image from November 16, 2016 at 22:49. On the right, HI1-A SREM image from November 16, 2016 at 18:09. A large pointy star appears in both images. A very large object in Figure 7 seems to be the same object that produced the image shown in Figure 8 below from November 16, 2016. At the time, I thought it was the sun, but now I realize that it must be another star, which is very close to the sun. This star is not spherical like our sun, but it has pointed ends, like a lemon. Ha! Also, this object appears in the HI1-A SREM images, which are derived from the detection of high energy particles I'm right next to Moffett and NASA. They're only a few minutes away, like 8 minutes away. We've had a lot of activity here the last 24 hours. It's supposed to be a closed military base, Moffett Field. Also, the object appears in the HI1-A SREM images, which are derived from the detection of high energy particles and cannot therefore have lens flares in them. Thus, this object cannot be a lens flare. We thus have evidence that possibly a few large stars are found close to the sun. And since there is evidence of the same object as seen in Figure 7 and 8, also having appeared in 2011, these stars must be orbiting the sun. And one of them must be associated to the object that caused the sun, to go dark during the so-called SDO eclipse season, which is a very controversial topic, it seems. I have written numerous articles that show that the images detected by the SDO satellite are not consistent with an eclipse and that the sun actually goes dark during the SDO eclipse season. I've also found 3 different periods associated with the event. The period of 361 days is the time it takes for the cycle to repeat itself each year, and another 2 periods of 178 and 183 days also emerge since the cycle repeats itself twice a year. The last 2 periods can be averaged to 180 days. Now, the object behind the Earth must have an orbital period very close to the Earth's orbital period of 365 days. So a period of 361 days would be a good match. This means that the object behind the Earth might well be a central star of what we call the dark sun cycle binary system, and that therefore that dark sun star which causes the sun to go dark orbits the central star. The object close to the Earth may therefore be the central star of a binary star system with a brown dwarf star or dark sun cycle star that causes the Earth or the sun to go dark orbiting it. This is illustrated in Figure 9 below. The orbits might be slightly elliptical, but I'm going to approximate them to circular and see what the equations give us. All right, so orbit of dark sun cycle, central star around the sun. Okay, this is this line here. Here's the Earth's orbit, a blue guy. The central star of the dark sun cycle star system is right here. The orbit of the dark sun cycle star around the central star in the system is right here. Figure 9 is simply an illustration of the object's orbits associated with the dark sun cycle or SDO eclipse season. These orbital radiuses of the dark sun cycle star or the central star of this binary system is RDS. I have previously done a simple calculation, but I assumed that the central star had the same mass as the sun, and I only used the period of 180 days. With this very simple calculation, I obtained the central star's orbital position to be very close to Venus's position. Now I'm going to also use the period of 361 days, and I'm going to also solve for the mass of the central object in the dark sun cycle binary star system. So, letting TDS equaling 180 days being the orbital period of the dark sun cycle star, or the star that passes very close to the sun and makes it go dark, TC equals 361 days, B, the orbital period of the central star of the binary star system, and TE equaling 365 days, B, the Earth's orbital period, we will calculate RDS, which is the orbital radius of both stars. In terms of the Earth's orbital radius, which is RE, which is equal to 1 astronomical unit, or 1 AU. That is the distance from the Earth to the Sun, 1 astronomical unit. That's like a base. Okay. And the mass, MC, of the central star. Using Kepler's third law, we have that the central star's orbital period for its orbit around the Sun is given by TC squared is equal to 4 pi squared over GMS times RDS cubed. Okay? Now, the Earth's orbital period is given by TE squared is equal to 4 pi squared over GMS times RE cubed, where MS is the mass of the Sun from equations 1 and 2, we can solve for RDS. RDS is equal to TC over TE to the power of 2/3 time RE. Now, which is equal to 361 over 365 to the power of 2/3 times 1 AU astronomical unit, which is equal to 0.99 AU. Now, the dark star's orbital period around that central star in the binary system is given by TDS squared is equal to 4 pi squared over GMC times RDS cubed. Pardon me. Where MC is the mass of the central star, using equations 1 and 4, we obtain the following. MC is equal to TC over TDS, all squared times MS, which is equal to 361 over 180 squared times MS, which is equal to 4 times MS. In conclusion, it is likely that the central star of the binary star system responsible for the Sun going dark has an orbital radius of 0.99 AU, which is only 0.01 AU astronomical units from the Earth's orbit, and that this central star is the same object, which is just to the left and behind the Earth in the HI1-A images shown in figures 1 to 7. This object, therefore, is likely to have a mass which is 4 times that of the Sun. The question is, then why this star has not caused absolute chaos in our solar system? I think the reason has to be that the gravitational force is not driving the force in planetary systems, but that electromagnetic and possibly the strong force may be playing a much larger part. I mentioned the strong force because that seems to be the only possible reason why stars are being attracted to our star. and are now orbiting it in large numbers. This is an indication that stars may behave like protons do in a nucleus. They repel each other because of the electrostatic force, but they attract each other because of the strong force. Chris Potter, thanks again of Physicist Thoughts. Have a great day.